Picture a wall with a single narrow slit and a screen behind it. Fire marbles at the slit, most are blocked, but a few pass through and hit the screen, forming a single bright band. That's what we expect from particles. Straight paths, predictable results. Now imagine sending waves, like ripples in water, at the slit. The wave squeezes through, then fans out, creating a broad, faded pattern on the screen. Particles make a sharp line, waves make a spread-out pattern. For centuries, this was the foundation of physics, particles and waves, each with their own rules. Particles are localized, waves are spread out. This experiment draws a clear line between the two. Our everyday world follows these classical rules. Solid objects act like marbles, sounds spread like waves. But what happens when we shrink things down to the quantum scale? Here, the familiar rules break down. This is where the strangeness truly begins. Now let's fire electrons, tiny particles at the single slit. Logic says they should act like marbles, making a single band. But as electrons hit the screen, a wave-like diffraction pattern appears. Each electron lands as a single dot, but together, they form a pattern only waves make. The electron behaves as both a particle and a wave. This is wave-particle duality. The electron is not just a tiny ball but a quantum entity with a dual nature. It travels as a wave but arrives as a particle. Which aspect you see depends on how you look. This shatters our classical intuition. The quantum world is far more mysterious than we imagined. Now let's add a second slit. Marbles fired at two slits make two bands. Simple, predictable. Waves, though, create an interference pattern, bright and dark stripes from overlapping ripples. What about electrons? Fire them one by one at the double slits. Each electron lands as a dot, but over time an interference pattern emerges, just like waves. Even when sent one at a time, electrons act as if they pass through both slits and interfere with themselves. This is superposition. The electron exists in a cloud of possibilities, taking all paths at once. It's not just in one place or the other, it's in both until measured. The double-slit experiment reveals the heart of quantum weirdness. Particles can be in multiple places at once. The universe at this scale is a web of probabilities, not certainties. Our classical logic simply doesn't apply. Reality is stranger than fiction. Physicists wanted to know, which slit does the electron actually go through? They placed a detector by one slit to watch. The moment they observed the electron's path, the interference pattern vanished. Instead, two simple bands appeared, just like marbles. Observing forced the electron to act like a particle, not a wave. This is the observer effect. The act of measurement changes the outcome. It's not about disturbing the electron, but about gaining information. Knowing the path collapses the wave of possibilities into a single reality. At the quantum level, reality depends on whether we look. We are not just observers, we help shape what is real. What have we learned? First, wave-particle duality. Quantum objects are both particles and waves. Second, superposition, unobserved, they exist in many states at once. Third, the observer effect measurement transforms potential into reality. The universe is not a fixed clockwork machine, but a dance of probabilities. Our questions and observations help shape the answers we find. At the smallest scales, reality is participatory. The quantum world is far stranger and more wondrous than we ever imagined. The greatest mysteries aren't out in space, they're woven into the fabric of reality itself, and every time we look, we help create the universe anew.